Hey buckaroos and buckarettes, it's good to be back with you. And in this short video I'd like to show you how to do Taylor series and MacLaurin series in Mathcad Prime version 11. Now I've gone over some of this stuff before in a longer video, and I thought it might help to just do one short one specifically on this. My apologies if you've seen this before. So let's start by saying what is a Taylor series or a MacLaurin series? The big idea here is that you can take any function and approximate it with a polynomial. And the longer the polynomial gets, the closer your approximate function is to the one you started with, the closer it is to the exact. So in case you've forgotten what a MacLaurin series or Taylor series looks like, I can just go into Mathcad right here, right here, and I can give you the equation for it, sort of the formula for it. Now, all I've done is type in f of x. Mathcad doesn't know what f is, it's just a function. I can go over here to symbolics under the math toolbar. See that right pointing arrow there? That means symbolic evaluation. That means Mathcad, you tell me something, but do it symbolically rather than numerically. I want letters, I want an expression, not numbers. And so I can either click there, it actually lives under operators too, I can find it right there, or I can just type in control dot, like that. Now, it just says f of x is f of x. Well, that doesn't help. Well, let's type in series, and hit return. Oh, look at that. This is a MacLaurin series. It's expanded about 0. So you can see f of 0, f prime of 0 times x, f double prime of 0 over 2 times x squared, and out and out and out. And you can see that that's a polynomial, because f prime or f double prime or whatever of 0, that's a number right there. That's a number. That's not a function. That in this case, that second derivative, I'll highlight it here for you, is being evaluated at x equals 0. Now, mathematicians speak about a function being expanded about a point. That means it's most accurate at that point. So a MacLaurin series is always expanded about x equals 0. A Taylor series is just a MacLaurin series expanded about some other point. So here's what we can do. Number one, I can make the series longer if I want. It defaults to 5 terms. I can go to, let's go to 8. There it is. Well, let's see if I can get more of this on the screen for you. Give me a second here. There we go. And you can see those 3 dots there. I can just keep going and going and going. Oops, there we go. Get it up. Now it says x to the 7th power. Remember, we have something to the 0 power right there, so that 8 means there's 8 terms in this series, not that it's to the 8th power. Let's get this back down to something we can show on the screen. So 4-term series. I'm going up to x cubed because right there, that f of 0, that's actually x to the 0 power. So there's 1, 2, 3, 4 terms in the series. That's what the 4 means. Now, can I expand it about some other point? That is, can I turn my MacLaurin series into a Taylor series? You bet. So I'm going to hit X, and I'm going to hit Control equals. Now, if you go on operators, this is this bold equal sign right there, and it's defining an equal to. It's basically an assignment. All right. Again, you're telling Mathcad something. So I'm going to hit that. I'm going to hit Control equals, which is the shortcut for that. And I'll just say 1. So give me that series, but expand it about 1. And there it is. Okay, so there's the big idea. And again, I can add terms to this if I like. See if I can expand that out just a smidge. There we go. Now, this works no matter what f of x is. So let's try this. Let me get rid of this. And let's try something simple like a cosine function. So I'm going to call, let's call it c of x. It's defined as, I'm going to say cosine of x, and then control dot, which is that arrow, and type in series, and I'll just let it go at that. All right, so this is a 1, 2, 3 term series. Now, and this expansion right here is assigned to c of x. So I can evaluate c of x right now. I can say c of 1 if I want. And there it is. There's the number. If you push 1 into that expression right there, you'll get 0.542. So it's 1 minus a half plus a 24th is that. I could use some other number if I wanted to. Also, if you want more decimal points, click under math formatting there. And see right down there, you can tell it how many you want. You can just keep going. This calculation stops at 4 decimal points. Doesn't go any farther than that because that's 6/10. If I gave it something else, 1/3 maybe. Yeah, see, I can get that to go on forever now because 1/3 goes on forever. Now there's a limit. That's the maximum number of digits Mathcad Prime will give me. All right, so there's what that looks like. Now let's try something here. Let's plot that against a cosine function just to see what we get. So I'll go to plots, and right there I will select XY plot. Now this is a little big. I'm going to smush this down. I'm trying to keep this big on the screen in case you're watching on a phone or something with a small screen. So there's X. There's cosine of X. Okay, that's cosine. That's what that looks like. And let's then add a second trace here. So I've got it. I've highlighted there. I'm going to go over to add trace. See, there's room for a second one. And I'll just say C of X. Now, a couple of problems I've got. The first one is that the y-axis is way, way, way too big. So let's go here and make it go from maybe -2 to 2. There. And the other one is I've got blue on black. Well, that's a good song actually, but it's a bad color for a plot. There we go. So now we can see the red is my approximation. That's my cosine function, what I've assigned to C of X. And then the blue here is the actual cosine. You can see it's periodic. Well, what happens if I use more terms in this MacLaurin series? Okay, there's not a 6th power there. Let's go up to there. Still not doing it. There we go. I don't know why I had to go all the way up to 7, but there it is. Got 1, 2, 3, 4 terms in it, but I've got a 6th power. Now, it's more accurate through, what's that about? Plus or minus 2.1, 2.2. Let's just keep going. Let's make this something really big. Let's go up to 9. Okay, that gives me an 8th order. That's interesting. It doesn't do that. There may be a bug in the software. I'm not sure. I just found that while I'm shooting the video here. I'll move this down a smidge. Okay, let's just stick with those odd numbers. There we go. There's up to 13th power, or 13th. Yeah, it'll go up to 12th power here. So there it is right there. Again, I'm not completely sure why it's counting like it is. But you can see that you've got an entire period of the sine wave, or the cosine wave, approximated really pretty well. Let's cut this back down to something more manageable. There we go, 4th order. Now let's say I only need it accurate in this short range here, but I'm not interested in 0. Maybe I'm interested in it being accurate around 2. So I can click there, say X, and I've used Control equal before, but let's just go up here and show you where this goes. Right there, okay, that highlighted equal sign, and let's expand it about 2. And what we would expect is the red line is close, or the red trace, I guess, is close to the blue trace around x equal 2 and gets less and less accurate as you get farther from that. And that's exactly what happens. See, right in here, it's quite accurate, but as you depart from 2, it gets less and less accurate. I can still increase the number of terms and get a better answer. See, there we go. So with x equals 0, I don't have to put this there, but I'll put it there so you can see it. That is a MacLaurin series. With x equal any other number, say 1, that's a Taylor series. So there you go. I hope this helps, and we'll talk to you next time.